Flip-flops. Objective: to design and implement SR flip-flop, JK flip-flop, D flip-flop, and T flip-flop. SR flip-flop. The circuit is used to store the single data bit in the memory circuit, so the SR flip-flop has a total of 3 inputs S, R, and current output Q. This output Q is related to the current history or state. The term flip-flop relates to the actual operation of the device, as it can be flipped to a logic set state or flopped back to the opposing logic reset state. The set state. The input R is set to false or 0, and the input S is set to true or 1. The NAND gate Y has an input 0, which will produce the output Q1. The reset state. R equal to 1 and S equal to 0. One of the inputs of NAND gate X is 0 and its output Q is 1. This is the characteristic table of SR flip-flop. JK flip-flop. The JK flip-flop is basically a gated SR flip-flop with the addition of a clock input circuitry that prevents the invalid output condition that can occur when both inputs S and R are equal to logic level 1. Due to this additional clock input, a JK flip-flop has 4 possible input combinations: logic 1, logic 0, no change, and toggle. This is a truth table for the JK flip-flop. D flip-flop. The D-type flip-flop are constructed from a gated SR flip-flop with an inverter added between the S and R inputs to allow for a single D data input. Then the single data input labeled D and is used in place of the set signal, and the inverter is used to generate the complementary reset input, thereby making the level sensitive D-type flip-flop from a level sensitive SR latch as now S equal to D and R equal to not D as shown. It will store and output whatever logic level is applied to its data terminal, so long as the clock input is high. Once the clock input goes low, the set and reset inputs of the flip-flop are both held at logic level 1. This is a truth table for the flip-flop. T flip-flops. T flip-flops is a simplified version of JK flip-flop. It is obtained by connecting the same input T to both inputs of JK flip-flop. It operates with only positive clock transitions or negative clock transitions. Here the inputs of JK flip-flop are considered as J equal to T and K equal to T in order to utilize the modified JK flip-flop for 2 combinations of inputs. Here Qt and Qt plus 1 are present state and the next state respectively. So T flip-flop can be used for one of these 2 functions such as hold and complement of present state based on the input conditions when positive transition of clock signal is applied. This is a characteristic table of the T flip-flop. Now I will be showing you the simulation of SR flip-flop. When S and R are both 0, the output Q dash is 1. When R is 1, the output Q dash is 1. When S is 1, Q is 1. And when S and R are both 1, it enters into invalid state. Now I will be showing you the working of JK flip-flop. When J and K are both 0, we get the next state. When J is 1, we get the output as previous state. When K is 1, we get the output as the next state. And when J and K are both 1, we get the complement of the previous state. Simulation of D flip-flop. When one input is 1, Q dash is 1. When the second input is 1, Q dash is 1. And when both the inputs are 1, Q is 1. Simulation of T flip-flop. When both the inputs are 0, the outputs keep changing according to the clock pulse. When E is 1, Q dash is 1. When both the inputs are 1, the outputs keep changing. Thank you for watching.